Okay, so support basically is just the proportion in which the antecedents and consequence occur. Confidence is the ratio of the number of times that the rule holds up. And lift is the additional probability that the consequent will occur given the antecedents. Now, support, let's talk about support for just a second. Support is just your basic measure of the proportions in which the items occur in the entire data set. So, do you want item combinations that have high support levels or low support levels? Generally low, because those are as antecedents. You want antecedents, combinations of the items as antecedents that have low support, because generally those are not obvious antecedent conditions. But in some cases, as we'll see, you want to have support measures that are above a certain threshold. Okay, so let's look at this one example. This is the online music, and we should have, what we want to have are records where each row, a matrix where each row is a person who listens to the radio, and the columns, the variables in the columns are the artists. So for each person, each row, in that row you would have zeros and ones, which represent whether they listen to those artists. But you can also have other categorical information about the user. For example, gender. We'll look at gender, or age. If you have age, you would have to partition it into categories because it must be categorical. Okay, and this application or this example was for a recommender system. You know, you want to recommend, somebody joins and they listen to The Doors and, Led Zeppelin. Based on your rules, you want to recommend to them additional artists that have a high lift on the right-hand side. Okay, so that's what we're doing. Okay, so let's see. We've got, here, let's take a look at this stuff. Okay, so I gave you the file. It's in your data folder. I really like these interactive functions in R by which you can choose both files. You can also set the directory. So this way you don't have to worry about where the directory is. So read CSV will just read whatever CSV file I point to with file choose. And note that here the window popped open. File choose is an R function that opens up a Windows-based, your operating system-based window that you can use to drill down. Sometimes it just shows up here in the toolbar, so you got to look for it. When it's waiting for you to do something, or if it's computing some large time-consuming algorithm, you get this little stop sign. In this case, it's waiting for me to do something, so make sure you look for the window. So anyway, we drill down, and there's our class file, and we're in session 3, and go to data, and we grab it, and it assigns it. Read CSV loads it in from your file, CSV file, which is comma separated, but additionally changes it to a data frame. And you can tell that, I'm using RStudio, of course, but you can see that this is the later version of RStudio. It has a lot of additional information. This is a large data set, 290 records, 290,000 records, and there are only 4 variables. So if we could pop it open in the screen here. Now note that this file is not in the format that I was just describing. What I was just describing is the so-called wide format, where what you want, as I just described, is you want each row to be a person, and you want each column to be an artist. Okay, this is the tall format, sometimes called long format, tall format, where the users are identified by a number. It's a factor variable. Well, it's not yet, but it will be. So for this first person, the one, and you might not be able to see this, it's a woman, there's female, a woman from Germany, but these first 16 rows are the same person, and it just lists the artists that they listen to stacked up on top of each other. But that won't work. We have to reformat this, restructure this, so that it can be processed by the a priori function in the a rules package. Okay, so it's always a good idea when you load a data set to try explore it a little bit to see what you've got in there. So dime is dimension. It returns the number of rows and the number of columns. And you might look at the names of the variables, just the column headers. So we only have 4. And it's always a good idea to look at the first few records. And we did that interactively. We did it with the view command. When you pop on this little icon, what that does, you can see it over here. It actually issues the view command with a capital V. It's a capital V. But you can also just use plain old scripting, subscripting, indexing. So we say, show me the first 19 rows, and it'll turn up over here, and this is the console. And this is probably a little easier for you to see because it's bigger. Length returns the number of records. Okay, so we've got to do something about this. This is a data frame. This object currently is a data frame because readcsv imported it as a data frame. But notice when we say structure, let's make this a little wider so we can see each one. Structure gives you a lot of information about, first of all, the type of object. Data frame tells you the dimensions. Then for each variable in the data frame, it lists the name of that variable, tells you what the data type is. So this one's a problem. We can't handle integers. An integer is numeric, and there are 2 types. There's integers and they're real. Real is a double, but those are both numeric. And integer is not continuous, it's interval, but you can't use it. You have to make it a factor. Okay, so when you represent either a number or a name, a label as a factor command, as a factor variable, each unique value of that number or that name, that label, is a level. So you can make a factor out of any variable, even if it's a vector of numbers, 1,000 numbers. You can make it a factor, and just each unique number becomes a level. Okay, so that's what we have to do. We've got a pre-process user, and so we do that. We say factor. We could also say as dot factor. That would achieve the same thing, I believe. As dot factor, it queries it first, and if it's not a factor, then it coerces it into one. Factor just changes it. So if we say make it a factor, note because it's a data frame and we did not attach it, in order to access a variable, you have to use the longhand name of the variable, which is the name of the data frame, $, name of the variable. So we do that, and we just replace the column. All it does is it changes the type to a factor.